So how's everybody doing? Been enjoying all the sessions? I've been having a lot of fun. Seeing some really good stuff about some plugins people have come up with. Distributed refactoring across GitLab or GitHub was a really cool one that I'm looking forward to applying ourselves. But this presentation, if you saw the keynote, is about doing visual analytics on data collected from your builds and using that to improve your decision making. This conversation we're going to have has 3 basic steps. I'll give you a little bit of context, which you're at the keynote, you probably already have. Then I'll jump right into some slightly more in-depth examples of how we used data collected with Gradle Enterprise and analyzed in Tableau to improve our developer build experience. And just talk a little bit about future steps, as we've only really just gotten started doing this in earnest. So there's many cool and interesting places we could take this to help guide us down that road to build happiness. And then at the end, I will discuss briefly how you can get this set up for yourself and do this for your own organization. So just a little bit of context. We're Tableau, I work for Tableau Software. We help people see and understand their data. We use our products, and we like data to inform our decisions. Gradle Enterprise capturing very granular build information made it possible for us to live up to our own mantras and aspirations in this regard for the first time. And I will probably slip into the habit of calling a data visualization a viz, as that's kind of a Tableauism that sticks with you after a while of working in and with Tableau. Just to give you a little context on our usage of Gradle, we have a bunch of C++ code that our Gradle build isn't really involved with. Instead, it focuses on the Java side and Tableau Server, which is a 300-ish multi-project monolithic build right now, although we're trying to move away from the monolithic part. We do have a few TypeScript projects, which if you were 2 rooms down a session before, a Gradle engineer gave a great presentation on how to build TypeScript and JavaScript projects with Gradle. And our approach is very similar to that. Build has historically been a source of frustration for developers at Tableau. I know it was for me personally, right? I was and am to an extent a product developer who works on Tableau Server. I never set out to become a build guy for our organization. It's just kept running into problems and that no one else wanted to deal with, and I'd go in and fix them one by one, and one thing led to another, and we're converting our Ant and Ivy build to Gradle, and suddenly I'm a subject matter expert before I know it, trying to help fix all our build's problems. So the build being a source of frustration and there being limited resources to deal with it, this ability to get insight into what the serious problems really are and to prioritize the long list of issues is really a powerful capability first brought to us in earnest with Gradle Enterprise and its data export APIs. Our other telemetry streams that we had before Gradle Enterprise were at just such a high level of granularity. Like it could tell you that somewhere in the server build a test failed, right? But why? Or that a build step failed, but which sub build step out of the some 5,000 tasks that comprise the server build? It just wasn't detailed enough to actually get to root causes without just a whole lot of pouring through logs one by one by one. So let's start with the first investigation. This was this is going to be slightly more rudimentary than some of the things I showed you in the keynote today, but this is really the point where we started from. The very first time I was able to bring Gradle Enterprise data into Tableau, this is the first chart we came up with. We have this amazing looking little line graph right here. I'm sure this is just mind-blowingly colorful and everything for all of you. What this represents is how long Checkstyle takes to perform on a single project. At this point in our data analysis journey, hadn't even really figured out how to properly visualize multiple projects, aggregate performance characteristics at once yet. So we know that at some point in the past, before we even started our Gradle Enterprise trial, this took 5 seconds, and suddenly it's taking 50 seconds for a single project to run Checkstyle. That's kind of ridiculous. We had been running the trial before this was even really noticed, and someone reported it to us, which probably says something about the state of inurement to pain and disappointment that some developers were living with, that it took them a little while to even get around to reporting that something about the build had gotten worse. But But once they did, I thought, I know, I'll check out this data we have, and found out that the original regression had come beforehand, before we even started collecting data. So the point at which it crept up, by a factor of 10 is unknown off in the past. But this data did show us that when we did attempt to implement a fix, that the fix fixed it, right? It dropped back down to that 5-second time that we all fondly remembered it being. So this was the point at our trial of Gradle Enterprise, where we really had something approximating a proof of concept that yes, we can use this data to get useful insight. So we tried to, so from that basis, we moved forward into our next kind of investigation. And this one I'll probably do live in Tableau a little bit more rather than just showing you screenshots. We had this weird thing, so I made this dashboard, which, let's just switch over to Tableau and see if I can't just show you this on the fly. So let's see, I have my failures dashboard over here, where each of these areas, as I kind of mentioned in the keynote, represents a particular kind of task failing with some frequency. And if I adjust the time period that this chart covers back...
We can't see anything yet.
Oh, right, because, thank you. Because I left this full screen. No, it's still full screen. One second. I have to exit presentation mode entirely. All right, cool. Yeah, I had to just alt-tabbed over to Tableau. Okay, so here's our dashboard actually live within Tableau, and if I edit the time window to show us the failures that were happening at this earlier point in the build, we see that the failures are dominated by these process resources tasks that are failing. And all of you who are familiar with the Java plugin know that the process resources task is just a file copy operation, right? It literally just copies the stuff from the resources folder in your Java project to a folder with the same name and contents in the build folder of your project. So this is a really confusing thing that would fail, as that's one of the most brain-dead straightforward operations that there is, right? Like, do we all have faulty SCSI controllers? Like, are we using the world's least reliable hard drives? Like, what is the deal here? So from this dashboard, let's see, looks like my corporate VPN connection has not been successful, so I can't actually jump back to my real Gradle Enterprise server back on the corporate network, but I have prepared a slide for this part. So we go and actually look at the build scans to see what they had to say, and notice a couple interesting correlations here. One, all of the process resources tasks that were failing with permission denied error, so not like some kind of weird hard drive failure. And it was always Linux machines, right? All of our developers who are on Windows never ran into this problem. Only people working on Linux encountered this issue. And we also noticed, we noticed that this would happen the second time the task ran. The first time it ran, it would copy successfully, and then subsequent copy attempts would fail, which is perplexing until we remembered that we were using Perforce, were and are in many cases still using Perforce for source control, and it is configured to set files to read only the first time. Or it is set to configure files to read only if they are not checked out, the equivalence being like staged for commit and git. So what we're seeing is that on Linux, at least under specific circumstances, which led to us filing this bug on Gradle, you would fail copies on Linux the second time you did it with read-only files, and occasionally if you did something weird, you could still kind of run into this. Like if you get the same file in a copy spec twice and they're read-only on Linux, you can still make this happen sometimes. Anyway, so having identified the read-onliness of the files as the problem and not being in a position to change our entire Perforce configuration to switch off that setting, we put in place this mitigation at the bottom where we just configured every single copy task across all projects to strip the read-only bit when it copied files. And so then, after we stick that code snippet in, did it actually work? Was that mitigation effective? Did the mitigation mitigate, right? So the fix went in, I don't know, sometime around here. And if I drag my data slider, yes, Yes, it did. All of those process resources failures went away. And part of why they were so prevalent is in the early stages of this trial, I had only a few people sending me build scan data. So the Linux guys, being very interested in the state of the build system, were disproportionately represented in that sample. So their problems showed up big and loud, which is something to remember, the biases in your sample, because you don't see how the sample is biased in the prettiness of the picture, right? At this point in the trial, I have 10 times as many people participating, but it still looks similar. So one thing to always be conscious of, how you can use visualizations to fool yourself, as well as to learn and elucidate. So let's hop right into the next subject, and I think I'll do this one primarily in Tableau. Touched on this a little bit more in the keynote as well, but let's go into some depth here. We were very interested in this build caching feature when we first heard about it, partially because some of our guys on the C++ and native side had put a whole lot of work into make kind of like home growing their own build caching solution to try and make our C++ builds faster. And after a lot of work and a lot of effort on the subject, they had gotten some nice performance gains in specific circumstances with specific drawbacks and caveats and problems and practices. So while I was very eager to improve the performance of the build for all of my Java developing friends, I didn't want to have to do that myself if I could possibly avoid it, but being conscious of the pitfalls involved in creating a caching system like this, even though I've been very impressed with the quality of Gradle's engineering at every opportunity to see it, I didn't trust necessarily that it wouldn't cause problems. So that was one thing I looked for when I started analyzing the behavior of the cache once we implemented that. So this slide probably looks familiar to many of you. At week 10, we enabled the local build cache. And at week 22 over here, we enabled the remote build cache and started having CI servers published to it. And we see that our cache hit rate went way up, but the number of failures we were getting during that time remained relatively unchanged from before we enabled the cache. Now, we only enabled the cache for the stuff that Gradle has by default enabled it, right? Only Java compile, test, and checkstyle tasks, because we were confident they had done their due diligence on those task types, made sure that the inputs and outputs were set correctly. So at least for these types of tasks, we did not see the failure rates increase as a result of turning on the cache, which was very reassuring. The last thing I needed to do was improve performance at the expense of correctness. So then the next question is, okay, you've gotten some cache hits. How much of a difference does it make? So on this chart, I plotted the average time that checkstyle tasks take and Java compile task takes and test tasks take when they are successful in their execution and when they are a cache hit. So you can kind of see that first chart I showed you where checkstyle performance was really bad. That's some of these early times. And so that fix is when you see it drop back down to 5, or I guess now most of our checkstyle tasks are actually executing in about 2 seconds on average on any given project. And a cache hit for checkstyle is slightly faster, I guess, except for this one time when perhaps network congestion caused a cache hit on checkstyle to even be ever so slightly slower than just running the task yourself. But we could see that on checkstyle you save like a second from a cache hit, at least with our particular configuration of caching nodes and our particular projects. For Java compile, the difference is a little bit more pronounced. I mean, these days it's just under 5 seconds typically to compile one of our projects, and it's about 1.5 seconds for a cache hit on a compilation. So for every project involved, we're saving a good 3 seconds there, which is pretty solid when you have about 300 projects that you might be building. That adds up pretty quickly across multiple builds. And the highest difference, as you might expect, are in test tasks, where we have a bunch of unit tests, which is what this is mostly considering, not integration tests. We haven't turned on caching on integration tests just because we don't necessarily trust that our product or the tests themselves are truly idempotent with respect to their inputs. There's lots of things that could go on in an integration test when you're bringing in network resources and databases and other things that make the test less deterministic but more real world. So these figures are constrained to unit tests. So we see that there's a big big time savings to be had whenever you get a cache hit on unit tests, which is on this next chart. You can kind of see in terms of like the time that based on the difference in each of those tasks, average execution time, the time I have estimated that they save whenever you get a cache hit, and therefore the time that the caching feature has saved us. Even though the cache hit rate for tests is much lower than it is for compilation, which is something I'm curious about and interested to talk to the Gradle guys more about their hypotheses about why this would be and what could be done to optimize it. Because clearly with that big time difference, a test cache hit is worth a lot more than any other kind of cache hit. But yeah, even with the lower cache hit rate, we can see that that overall, a decent amount of time, in this case amongst my 40-ish trial participants, they collectively saved almost 15 hours this week and almost 15 hours this week on skipping unnecessary unit test executions. So, cumulatively, a lot of time was saved. One interesting thing is here I have each of these rows represents an engineer and how much time I estimate that caching has saved them on each of the 3 types of tasks. So you kind of see that different people have different kinds of workflows that are different, have different likelihoods of encountering the cache. Some people, like this guy, I think like to do a lot of big full builds and then clean and do a big full build again. So he's going to encounter a lot of cache hits and save a lot of time overall. Whereas people who are a little bit more judicious about building only the few projects they care about, there's just less potential time savings there given those workflows. So yeah, we could see that like this guy is estimated to have individually, personally saved 15 hours from the caching feature over just a few weeks, that's pretty amazing. Like that's a couple work days back between stand-up meetings and planning and everything else. Maybe you get like 5 hours of work on a good day if you're not staying late or coming in super early. He got a couple days back. That's awesome. Good for him. I want to figure out how to further extend the cache hits and the benefits to more people after seeing that. Let's see, not interested in that tab right now. Let's see, what was the next section I had after? Oh, so that's caching. Pretty happy with the investigation so far. Kind of our next steps or next thoughts on caching is right now, like I said, I have this enabled for like 40 people. I'm going to get this turned on for like all 200-ish of Tableau server developers soon, in which case we might see more saturation of the network link to the server. We might want to spin up multiple nodes now that we know that that's possible, which is pretty cool. But when we do, we will have the capability through this data to see how adding those additional people into the system affected its utility, affected how much benefit it provides, and react accordingly based on real information. So let's look into Perf just a little bit more. We can see from some of our build scans that we have some really long running tasks. Most often it is test tasks that are kind of the long pole in a build, but every now and then there are other types of tasks. So we thought we'd take a look at what kind of tasks are costing us time. Now I don't know how legible. I'll make this a little bigger. Let's see how we can get this a bit more readable, because I don't actually have this Tableau workbook with me today. So this graph is a little hard to read. I should have better anticipated the resolution of these screens, but in any case, these are the different types of test tasks. In the left-hand side is their duration. The blue bar is an end-to-end test, right? It actually starts up Tableau server and does some things, so it's expected that one would take a long time to run. Then the more surprising result is that the orange bars, which on this chart represent unit tests, the next 4 longest duration test suites are all unit test suites. I might have naively assumed that it would be some of the integration test suites that take a long time. But this data shows us that these 4 projects have just so many unit tests that they take, see what we got on the x-axis, average duration seconds. Those projects each take individually like 2 minutes to run. Task execution for our entire build with parallelization turned on tends to be about 12 to 14 minutes. So merely the existence of a few of these kind of like long pole unit test tasks can play a significant impact on the overall length of the builds. Because if these projects have dependencies on one another and they end up running sequentially, your build could never be shorter than the duration of those tests lined up end to end. And we see from the right chart, which is just the number of records involved for each type of test, that the unit tests are run all the time and the integration and the end-to-end tests much less frequently. So you can kind of see there the relative importance of optimizing those test scenarios first. But test tasks aren't the only kind of tasks that take up time. We also looked into the slowest non-test tasks and found that the chart was dominated by those relatively few projects we have that are built with TypeScript. And we recently switched to using, we used to have all of the JavaScript dependencies for those tasks checked into source control, which was kind of miserable. It made it very hard to update. The files being read-only in Perf, and you had to check out all like 10,000 of the node modules file, do the update, then revert unchanged, and then repeat that iteratively when things broke until you finally got to a point where you could check things in. So moving to Yarn to do dependency management for web clients was a big win in terms of ease of updating dependencies for those web clients and keeping them current. But it's also really slow compared to a lot of other tasks to go and download like 10,000 little JavaScript files and stick them in the node modules folder. And then the clean tasks for those folders are similarly slow just because there's so many files inside them that the file system is struggling to keep up with the request to delete everything. So haven't figured out exactly where we're going to go from this in terms of how to optimize these things, but having identified the problem is the first step towards solving it. And a lot of times, if you're working on the Java stuff, you can just not run these tasks, right? If you're not working on the web clients, you're not gonna run these very often. So without frequent incidents, maybe it's acceptable that these tasks take a little bit longer. Let's see. So now we could talk. So that's kind of the analysis that I have done so far with the data that's available to us, even from this relatively brief trial. So you can now kind of talk about future subjects of investigation. One piece of analysis I did not complete, but I'm interested to look into in the future, is how are builds different? We often talk about a build A or build B like they're the same thing, but in a 300 project multi-project build, if you're building one project, you might be executing 15 tasks, and if you're building all of them, you might be executing 5,000 tasks. And you call both of those things a build, but it's very difficult to compare them in any really meaningful respect because they're so different just in scale. So here I have something of a histogram showing how many builds that my trial participants have run take a particular amount of time. And we see that the majority or a plurality of builds, the largest individual bucket, is builds that take 10 to 20 seconds or under 20 seconds would go in this bin, which is great. I kind of personally think of, and there's a little bit of research to back this up, but I kind of tend to think of like 30 seconds as like the Reddit line or the Facebook line, wherein if your build starts taking longer than that, you might lose that state of flow, not continue thinking about the development you were working on, and instead go to the internet for a detour that is who knows how long, and includes however much overhead for getting back to the task you were actually trying to work on before. So what I want to figure out how to do in the future is determine how many builds a particular optimization would make faster than that 30-second time. How many builds could a particular performance improvement or usage of the cache bring below the Reddit line? And then if there's a performance regression, how many builds did it kick over that point? As another tool for prioritization and analysis. In addition, one thing that was interesting to me is how different people's behavior in building is. Now, I really don't want to be like Orwellian or Big Brother-ish about this, start sending people's managers emails like, I noticed Tim hasn't been building very often. Is he doing any work? But just from an analysis point of view, you kind of see that some people, and this is counting number of tasks executed by various different individuals, that some people are just building all the time and are running, millions of tasks at the higher end over a period of a few weeks, which is kind of astonishing. And this purple color represents up to date. Think how miserable these people's lives would be if Mr. Brewer here if his 700,000 task executions that were up to date had all actually ended up consuming real processor cycles, he probably would have been substantially less effective at his job. So it is interesting to see from this that there are different kinds of builds and also different kinds of builders in terms of their interactions with the system. So I'll be very interested in future investigations to kind of like bucketize this. And I'll probably talk to someone who knows a little bit more statistics than I do about how to properly apply like k-means clustering or something to rigorously be like, yeah, these guys are kind of like your medium builders, and these guys are your heavy builders, and these guys are the light builders, and they all have different needs and respond to different stimuli in terms of the performance characteristics of the system. So when you're talking about an optimization or a regression, in some cases it might make sense to do so in terms of a specific audience or demographic that can be made apparent to you through numerical analysis. This kind of chart is one that I just whipped up, which I think these kind of box and whisker plots show failure rates. Each column is a week, and then this is number of failures encountered by individuals, so you can kind of see how reliable the build was on aggregate for people in any given week. And I believe I have removed from this chart compilation, checkstyle, and test tasks, with the anticipation that those are most frequently caused by user error. You forgot a semicolon, you broke that unit test, you violated the checkstyle rule. So this is intended to be merely a measurement of the reliability of the build itself. And so we see it at sometimes, and particularly early on when I had few participants, this was easily skewed by a few people who clearly had very bad weeks of building and probably had their productivity substantially hampered by that. We can see that sometimes there's huge variance in how reliable the build is and how many failures people encounter. And once I add more participants to the trial, or really make it not a trial at all anymore, involve everyone who builds Tableau Server in this data collection and analysis, we may get our clearest picture ever of how reliable or unreliable the build truly is. Like just recently, like this dot at the top here, this person encountered 64 failures in non-checkstyle, non-test, non-compile tasks in their build over the span of a week. So in each day, that person was running into like 11 or 12 problems. Now, maybe they were working on something particularly experimental or problematic, but clearly they weren't alone. So this, in encountering many problems, although some people ran into very few failures, but maybe they're the infrequent builders versus the frequent builders, and that kind of categorizing of people or categorizing of builders would be particularly useful here. Either way, this kind of shows us the work we have left to do, the long tail that remains to get to that point of build happiness that we all kind of came to this conference to learn more about how to achieve. Okay, so one other category of failure that I haven't figured out how to investigate yet with data, but I have some ideas, is failures that are displaced in time or space throughout the build. And this is particularly relevant when you have a custom task that has some inputs and outputs, so Gradle thinks it can skip it sometimes, or thinks it's cacheable, but you have listed those inputs and outputs incorrectly or incompletely, so perhaps it does not run when it really needs to. So you've got a code gen task or something that produces an input to another task that is incorrectly labeled as up to date and therefore skipped by Gradle through no fault of Gradle's, purely through the fault of the author of that task. But then the problem shows up sometimes later, and it can be difficult, even with all the detail of a build scan, to backtrace to the source of that failed up-to-date check. So I'll be looking into that more. And in many of these analyses that I've shown you so far, I have omitted the checkstyle, the test, and the compile tasks, as like I said, they are most likely to have active changes in them from someone working on their source code. And so when you're talking about the reliability of the build, we've kind of parsed some of those out in the data. But we can hypothetically use custom values to track that information. of like what files they had open in Perf or what files they had edits in Git, and then say, okay, if you had a compilation failure in another project than one you had any edits in, particularly if it was a dependent project of one you were working on, so your changes couldn't reasonably cascade downstream, we could probably say that failure was likely not to be your fault and worthy of deeper investigation. In a large interconnected build, this kind of, was this problem my fault? Did my change have a ripple effect? Is potentially a very useful thing for improving people's productivity and experience of their work. Okay. So let's see. We've been going pretty quick through this stuff. Is there anything else I wanted to show from the data I have? I don't think so. All right, let's go on briefly how to set this up yourself. So all of you have Gradle, and all of you could have, use if you get Gradle Enterprise, the data export APIs are not available on the hosted offering of Gradle. I think that'd be a cool thing to have. I see a few people in the audience you could bug to add it. But in the meantime, if you want to do this kind of aggregate data analysis on your build data, you need Gradle Enterprise, and you need your build set up to publish to it. And after you've done that, there's this open source project created by some Gradle engineers and maintained by William in the front row here. You can direct to him all of your feature requests. You can use this tool to dump, to export information from the data export APIs on your Gradle Enterprise server to a separate PG-SQL database, which Tableau then knows how to connect to directly. And once you have that information in PG-SQL, connecting Tableau to it is incredibly simple. You just tell Tableau what user account and credentials you want it to use, the address and the port, and all of your data is right there. And you can start making business immediately. Now, I heard William talking about this a little bit right beforehand. Why no web data connector? Tableau has we have an SDK that will enable you to tell Tableau how to talk to any kind of data source it doesn't already know about. It knows how to talk to Oracle, it knows how to talk to MongoDB, it knows how to talk to just about every kind of relational database and several non-relational databases and Excel files and CSV files and JSON blobs that already exist. But it doesn't know inherently how to talk to a RESTful web, an HTTP API. So if you want to teach it how to do that, you can use something called a web data connector, where you, or I perhaps in this case, supply a bit of JavaScript and a bit of HTML, which will talk to that API on behalf of Tableau and extract data from it. So the only reason there isn't one of these is because Gradle already provided me GE export, so in and amongst all my other priorities and things I have to do, I was at least temporarily saved from having to write one of these myself in order to bring this data into Tableau. I would like to create one of these, but I make no promises, except that if I do create it, I will release it as free and open source. And if any of you perhaps are particularly interested in creating a Tableau web data connector for this kind of data source, have previous experience doing so, we have a volunteer. You can talk to me on the Slack channel or something. I can give you my contact information, and we could perhaps collaborate on that process. So really, that's my whole presentation. That's what I have. What questions do you guys have for me? Yes?
Yeah. So basically, you said that you were estimating possible saturation of network channel, right?
Mm-hmm.
Because you keep getting new users. Have you tried to estimate whether it will be the first to saturate the network channel versus if you're massively utilizing build cache and users run huge builds, whether it will be saturate the I/O bandwidth on the server? I'm asking because we originally estimated that, and we decided to switch a little bit and use in-memory partition. We less care about retention, but more about bandwidth.
Mm-hmm.
Do you have any information, any estimation on this?
So the question was about most efficient utilization of a remote network cache. And I had alluded when I was talking on this slide to anticipating that saturating the network connection to the server might degrade the advantage of a cache hit relative to executing the task in Gradle directly. Is that an accurate representation of your question?
Yeah, mostly. But again, I'm mostly interested against saturation of a network channel versus saturation of I/O bandwidth of the server.
Yeah, absolutely. So he's asking, would that or how would we attribute that degradation, that hypothetical, at least in my data, degradation of performance to network saturation versus I/O saturation on the servers running the remote caches? And that's a good question. The data we have here doesn't know whether it was network constrained or I/O constrained on the server. We'd have to make an additional data stream available, perhaps based on diagnostic information from the server itself that was saying, hey, at this point in time, which you can then correlate to the time that the requests were executed, my disk was at this this percentage of its total I/O capacity, or my network was at this percentage of its total I/O capacity, and from that you could try and determine more deeply what the problem was. But yeah, just in the data exported from Gradle Enterprise at the moment, that information does not come with the build scan. So that is possible, but not an automatic thing to be able to investigate. I think if we get to that point of our remote cache not performing as well as we would like it to, what we might do is just SSH into it during peak hours and manually inspect those things, and that won't have the rigorous or the overtime aspect of empirically making that determination, but it would give a good hint as to what the problem was. Yeah. Any other questions? Yes.
Hi, Sam.
Hey.
You mentioned you didn't want to get Orwellian when you were showing individual developer statistics, but as I'm also trialing Gradle Enterprise for my organization, I'm a little bit worried when we roll it out. People are going to, if there's actually a way to possibly do this, hate the build team even more than they already do. Right? So, have you faced any blowback in your trial group, or is there any mitigations you thought about as you roll this out to all the Tableau?
I have so far not faced any particular political or personal blowback from this. And I think part of that might have to do with Tableau's very open internal culture. It's a culture where people are generally nice to each other, right? Where we make an effort not to be jerks. And that's kind of been reflected over time in people mutually trusting one another. The baseline assumption is that people are acting in good faith, so that when you see on the chart that some people don't run as many tasks as other people, it's not like, oh, those slackers were lazy. It's they were helping out on architecture, they were doing code reviews, they were doing tasks that don't involve building at any particular moment, as many important and value-adding tasks do. So I think part of why I haven't gotten any blowback is that many aspects of Tableau internally are run through metrics and put on charts and visible to everyone. Like, if I wanted to, I could go and see every deal that a particular salesman had closed, and that's just on the internal Tableau server, right? So part of that is cultural. As far as potential mitigations, if you did not feel that you had that trusting and open and non-recriminating culture, you could easily customize GE export or the hypothetical Tableau Web Data Connector to hash the names of people, right, and hash the host names. So you wouldn't have T. Schumacher did something, you'd have user 543 or whatever, and so long as your hash algorithm was idempotent, that would be fine. You could semi-anonymize the data through all the normal techniques. Good luck with that. Let me know how it goes, man. Any other questions on? Yes.
Does GE export does that extract the custom tags?
It does extract the custom tags. And the question is, does GE export extract the custom tags and values? It does. The way it does it, yes, and the question is, can Tableau filter on those? I have not done that in this particular analysis, but like I said, it is my intention to do so. The way GE export is currently programmed to dump custom values and custom information captured in a build scan is it doesn't turn the keys into columns in the SQL table. It turns them into, you have there's a column for keys and a column for values, which is just it's all the information is there, but it's slightly more annoying to work with in Tableau. So for now, just for now, I've skipped that to simplify things for myself. So The short answer is yes. The slightly longer answer is yes, but it might be slightly annoying. And the longer answer is yes, it might be slightly annoying, and in the future, I or one of you will tweak how GE Export does that, or tweak a web data connector to make that perfectly straightforward. Any other questions? Yes, I think I saw your hand go up first.
Does the Gradle Enterprise give you any information about identifying platforms? In other words, the user's workstation or details about the workstation? And have you used that to learn anything important about what you should or shouldn't do with respect to developer workstations?
So the question is, does Gradle Enterprise, do the build scans capture information about the platforms developers were executing their builds on? As I showed in the investigation into those process resources failures, the build scans do capture, like they were running on Linux, this was their host name, the processor architecture was x64 as opposed to 32-bit, and a few other metrics like that. And any other metrics beyond the ones it captures about the individual workspace could be captured as custom values in addition to that. So some of that information is already available. If you determine that more was necessary, you could additionally capture that. So far as what we have noticed about developer workstation, or about the role a developer's workstation or particular configuration plays in the reliability and performance of their build environment, have not particularly looked into that. We have, like I said, we have kind of a bunch of people working on Windows and a smaller number of people working on Linux. And in the early trial, the Linux developers were somewhat disproportionately represented in my data because they were very enthusiastic about this subject. So I haven't tried cutting and comparing like how Windows builds look versus how Linux builds look. My impression from the less empirical, more informal communications channels is that people have similar sets of experiences and frustrations across the company, regardless of their platform of choice and regardless of most other aspects of their machines themselves. Does that answer your question?
It does, yeah. I was wondering if it would confirm sort of an anecdotal observation that the Windows seems to take a bit longer to build.
Yeah, it's definitely true that on our C++ builds are way faster on Linux than they are on Windows. I think part of that is some clever developers optimizing how they invoke Clang. Have not noticed from the Gradle build side a substantial difference between Windows and Linux, but now that you mention it, I'm interested. I will look into that at some point in the future. And I believe William had a question.
Well, so I'm curious about, so what's your plan going forward? So you roll Gradle Enterprise out to all of your developers. Are you just going to happen to periodically go up and say, I'm going to run some Tableau reports? Like, is that going to be, is like your vision for that to become part of the process and the reports to automatically be run and generated and then you just look at them? Or what's your vision?
What's the vision?
What's your viz?
What's my vision, William has asked, for how does this information start to become part of our process? How does this improve our development experience, our development environment in the long term, not merely as a one-off, oh, look at that chart, ain't that cool kind of thing. And I think the most obvious current example we have of that is we've already started using this, where'd my dashboard go? We have already started using I have to break this into multiple workbooks to make it more manageable. We've already started using this failure rate dashboard to prioritize defects with the system, right? You have a bunch of defects. Which one do you go for first? The one that affects the most people. Easy. It has already made a difference in ensuring that we're going for the most impactful changes first. I imagine that this chart, or an evolution there of it, will be part of our triage and planning purposes for a long time to come. As time goes on, this data will be available to everyone. Like I said, we have a very open internal culture where everyone is encouraged to do any kind of vizzing or analysis on any data source that is made available to them. So I look forward to seeing what my fellow Tableau developers will come up with. Now you asked, part of your question was about the management of this, I think more the logistics, the brass tacks, the when do you get out of helping to maintain GE Export? No, I'm attributing motives that were not expressed in your question. Forgive me. the question was, is this like a one-off thing? Am I manually going to do this? No, my intention is that in the short term, I'll set up GE export to run as like a cron job, like every hour, and just export the last hour of data to the PG-SQL database. And the Tableau data source I published to our internal Tableau server instance, I will similarly set to refresh the data every hour, so that we'll have, at least to begin with, like an hourly latency. And we'll see how that keeps up with a bunch more data coming in, and whether that affects the performance of Gradle Enterprise during peak hours. I'm not anticipating that it will, but we'll see. The data will show us. Any other questions? Yes.
Have you shared, or can you share some of the workbooks that you've set up?
The question is, have I shared or can I share some of the workbooks I've set up? It's an excellent question, and I would like to. Right now, all of the data I'm showing you is our real data from all of our real developers, which contains within it all of the internal structure of our closed source and proprietary projects. So I am not at liberty to share that data. If I have, so I would either have to come up with a synthetic data set, which I could attach to the workbook and then happily publish on Tableau Public for all of you to download and adapt to your own organizations and data sources. Or use some kind of fuzzing tool to take our data and make it not be our data anymore, such that it wouldn't represent any kind of intellectual property or copyright risk to share. So the answer is I would like to, but I am not making any promises. What I can promise you is that this is very easy to do with limited knowledge of Tableau. I am not a Tableau expert as a user of the system. Yes, I make Tableau, but really I should put an asterisk and be like Tableau server, because you're writing. A lot of you guys write server software, right? Is it sometimes what you're serving to your job as a server developer? Is it MP3s? Is it documents? Is it Git clones? Meh, you just want it to be available all the time. So it is a somewhat shameful point, but I am not an expert user of Tableau Desktop, which does mean that it won't be too difficult for anyone else who's not an expert of Tableau Desktop to achieve parity or surpass my efforts in these analyses. Any other questions? And how am I doing on time? Is the next session supposed to be starting or anything? We good? Break? All right, so we could probably take one or two more questions if anyone has any. No? We're good? Yes?
Would you offer this as a service if people want to just send you their code?
Would I offer this as a service if people just want to send me their code? I am not particularly well versed in this side of our business, but I do understand that Tableau does offer in consulting services, both on its own and through a variety of partner companies. So I'm sure that if you want that, it could be arranged. All right, thank you all very much for attending my talk. I hope it was useful and interesting to you.